Welcome everybody to the first webinar of a series of webinars that we are organizing at D-Carbonize. And this first one is about how to measure a CO2 footprint for the first time. So I guess if you are here today, it's because that you may have wondered already that question in your mind, and we will do our best today to bring the most important principles, the most important information you should be aware of for this topic. Before we start, some very important information we would like to share. First, this webinar is recorded. It's recorded so that you will be able to access the replay of this session. We received quite a lot of requests from people who could not, unfortunately, attend today, but they would enjoy the recording of this session. If you have questions you would like to ask us, because there will be 10 minutes at the end of this webinar to ask us questions, please use the Q&A system. Thank you very much already to all of you who sent us in advance your questions or your thoughts. We did our best to customize this presentation to address your concerns and your questions. During the presentation, please try to avoid to unmute your microphone, and it's to guarantee that everybody can listen without disturbing noises. And well, feel free to open your camera, but be aware that a Teams meeting with a camera is an increase of 96% of CO2 emissions. So better to be aware of that already and to start measuring our CO2 emissions. Today, I'm very lucky to be with my colleague, Iris Dehorte. She's the Chief Compliance Officer at D-Carbonize, and she's literally in charge of making sure that our product and our services are meeting constantly the requirements, the obligations from the climate laws, especially at a European level. And Iris has a fantastic background of 10 years in legal, in compliance, and in finance. Welcome, Iris, and thank you very much for preparing this session.
Experience in several consulting firms in the past, and he has conducted more than 100 carbon footprint assessment for clients. So he has a lot of expertise, and I'm always amazed how much knowledge he has. So feel free to ask him as many questions as you have. Also about the agenda of today, we are going to, well, I would like to introduce maybe D-Carbonize quickly before. So D-Carbonize, we are, our mission is to help companies to measure and reduce CO2 emissions. So actually companies cannot reduce the emissions that they do not measure. That's why we have put at their disposal a software that we have developed in-house, which allows companies to track the emissions, to identify the major source of the emissions, to plan a decarbonization strategy, to measure also the carbon footprint of their products. And because we understand that this might be challenging in the beginning for some companies who might not have the knowledge in-house, we also have a team of experts, a team of consultants, which are very knowledgeable in carbon accounting, which can help them with this journey. So our software is actually certified by Solar Impulse and is complying with two methodologies that are well known in carbon accounting, which are bill and carbon and greenhouse gas protocol. We are also supported by very solid investors, and we have conducted carbon footprint assessment for more than 40 clients in 12 countries. With regards to today's agenda, we are going to start with an environmental awareness session, because it's always important to know why we do what we do and the impact of human activities in the environment. We are going to continue with a carbon accounting foundation, which is divided in the carbon footprint methodology and also in a case study to share some practical insights. And we are going to finish by a session with questions and answers, where we encourage you to ask as many questions as you have.
All right. Well, thank you very much, Iris. Well, as you rightly mentioned, it's very important to understand why we are measuring CO2 emissions, and the obvious answer is to fight climate change. Okay, everybody knows that, but what are the connections? And this is what I will try to make for the next 15 minutes or so. So let's start by the beginning, I guess. And the beginning is all about the greenhouse gas effect. First, let me tell you that the greenhouse gas effect is a natural effect. It's an effect that we need to ensure that our world is livable. So I will not go into too much details, but I just want to make sure that everybody is familiar with this effect. And as you know, we receive energy from the sun. Part of this energy is sent back to space because it encounters clouds or aerosols or any other surfaces that may reflect the energy towards space, which means that the rest is captured by our planet. And in our planet, we have two sorts of surfaces. One is Earth, and the other one would be water, oceans, seas, and so on. So our planet is warming with the energy captured by sun rays, and then, like by radiation, this energy is sent back into our atmosphere. Part of it is sent back to space, and that's the point number 4. But another part is trapped by what I will call as a blanket. It's trapped by greenhouse gases. And these greenhouse gases has the power to reflect this energy down to the surface of the Earth. And the more you have greenhouse gases, the more energy is reflected back to Earth. And it's a bit like in the winter when you sleep with a blanket. The thicker the blanket is, the warmer you are below the blanket. Well, here the blanket would be the greenhouse gases. And the more you have greenhouse gases, the warmer it is. And that's a very important mechanism to understand why we are doing a carbon footprint assessment. Speaking of the greenhouse gases, unfortunately, and you know this graph, I'm sure better than me, it's increasing since the Industrial Revolution. And the reason is simple, because since 1850, we are using fossil fuels. And fossil fuels, when they are used, consumed, they emit what we call greenhouse gases. Now, a very interesting point to analyze is by how much did we reduce greenhouse gas emissions during COVID-19? Now, put yourself back during this tough time. Remember, we were locked at home. We could not go to a restaurant. We could not buy almost anything. We could not travel. Lots of manufacturers were stopped. By how much percentage do you think that we decrease our greenhouse gas emissions? Well, now, thanks to the data that were collected from this period, we are able to assess that roughly during COVID-19, greenhouse gas emissions at the global scale decreased by 5.5%. Was it the number that you had in mind? Usually people would think around 10, 20, 25%. I was personally quite impressed by how little it is, 5.5%, but that's a personal opinion. The good news is, if you are looking at some major regions, let's say Europe or North America, for the past 10 years, we are decreasing our CO2 emissions at different rates, but certainly we are decreasing our CO2 emissions. So keep that number in mind, 5.5%, because you'll see it's a very important ratio. Now, these are absolute numbers of greenhouse gas emissions, but where are they coming from? Very important to understand. As I mentioned, from fossil fuels. Yes, from the energy that we are using. In fact, almost 3/4 of the greenhouse gas emissions emitted in 1 year at the global scale come from the energy that we use. And the energy today is highly carbonated at a global scale, and this is why we have greenhouse gas emissions. And the rest, it comes from agriculture, forestry, and so on. So for example, when you have cattle, it creates greenhouse gas emissions. Waste, landfills, they create greenhouse gas emissions, the chemical reactions. Same for the industry, cement, chemicals, and so on. It creates CO2 equivalent emissions that is not directly related to the use of fossil fuels. Altogether, they are greenhouse gas emissions, and it participates to global warming. And global warming is the increase of the average temperature around the world. And the IPCC, you know this group of experts that monitor the evolution of climate change, came up with this graph that I find very interesting. They try to distinct the impact of greenhouse gases from natural sources versus human sources, and what are their impacts on global warming. So the green line, if you see, is quite flat, meaning that it doesn't really impact global warming, and this green line is represents greenhouse gas emissions from natural sources. So they could be, for example, volcanoes, natural forest fires, and so on. And the other line represents the increase in temperature, the global warming from greenhouse gas emissions emitted by people, by us, by humans. And as you can see, while we are around today, plus 1.1, 1.3 of global warming. I recently read a report from Copernicus. Maybe you know this research institute, and they measured that in September, at a global scale, just for the months of September 2023, global warming was at 1.75 degrees in September 2023. So it's not around the year, of course, it's a bit lower annually, but climate change, at least global warming, is accelerating. So now that is for the past. What about the future? Well, the future depends on us, right? It depends on how ambitious we are with our policies and how active we are with the actions that we implement to reduce our carbon footprint professionally, but also in our private life. So let's review this graph here. If we do nothing, let's say there's nothing in place, we could go up to plus 5 degrees of global warming, which maybe or maybe not a lot. We'll see about that in a moment. The other opposite is to meet the COP21, the Paris Agreement, to stay below 1.5 degrees of global warming, or at least to stay well below 2 degrees of global warming. And in between, well, it represents kind of where we are going today with our current regulations and with our future regulations that are expected to happen. And in that case, we expect global warming to be around 2.5, 3 degrees. But again, we don't have the crystal ball. It can be higher, it can be lower. You remember that during COVID-19, I said that greenhouse gas emissions decreased by 5.5%. Well, if you look at the curve of the 2 degrees pathways or the 1.5 degrees pathways, to meet that pathways, we would need a decrease of roughly 5% of greenhouse gas emissions every year for the next 40 years, 4 decades, meaning that the reduction of CO2 emissions should be equivalent to what we experienced during COVID-19, but for the next 4 decades. So the challenge is there. We certainly do not have to minimize it, but it's possible, and it's still possible, and it starts by measuring CO2 emissions. It's very important. So as I said, our global warming could reach 5 degrees. And I will tell you something that planet Earth experienced not long ago, a delta of 5 degrees in its global average temperature. When was it? It was not long ago, at the age of the Earth. It was during the last ice age. The last ice age was 20,000 years ago. And indeed, we had at that time a delta of 5 degrees compared to the natural temperature that we should have in our period. So right now, if you look at the scale on the right-hand side, we should be around 13.7, 14 degrees Celsius as a global average temperature. And during the last ice age, it was 5 degrees below. Remember, I said that the greenhouse gas effect is natural and needed. And in fact, it's true, because if we didn't have that, well, we would have a global average temperature of minus 18 degrees, which would make life very, very difficult to survive. One interesting aspect is that during the ice age, the global average temperature was still very positive, 8.7 degrees, and not equal to 0 or below 0. And today, we are roughly around 15 degrees Celsius due to global warming. So if we step back a bit, I try to share with you a bit of a history of climate history. If we go back to 20,000 years ago, we had a delta of -5, -6 degrees. And it took roughly, as you can see on the visual on your left-hand side, it took 10,000 years ago, 10,000 years to warm up of +5 degrees. And the real challenge is that right now, due to global warming from human activities, well, we could have an increase of temperature of up to +5 degrees, not in 10,000 years, but in a century or a bit more than a century. And this acceleration that is kind of dangerous, let's say, because it's very difficult to predict what will be the impact due to the speed at which we increase our temperature. So, as I mentioned, it's very important to stay below 2 degrees Celsius, and I would like to share with you some of the reasons why it's important to stay below 2 degrees. First, because you will have accelerations of natural effects that will start happening as of a global warming of 2 degrees, or more or less 2 degrees, according to experts. And one of the most well-known one is the fact that permafrost is melting. So first, what is permafrost? So visually, permafrost could look like the lens that you would have outside of your house, or the land that you could see from the window where you are sitting right now. The particularity is that the underground of this land is frozen for more than 2 years. As long as you have a layer of land that is frozen for more than 2 years, this is what we call permafrost. Now, permafrost covers quite a lot of surface around the Earth, and this is what I would like to show you with this graph that shows what is qualified as being permafrost, shown in blue in this map, at a global scale. And it represents roughly 25% of the lands of the North Hemisphere of planet Earth. So it's a lot of lands. And the issue is that because it's melting, it releases greenhouse gases and all other sorts of viruses, bacteria, and so on that we are not very familiar with. But what's sure is that when the permafrost froze at the time, it captured greenhouse gases, and it's normal that when it melts, it releases greenhouse gases. That's only one of the multiple effects that you could find, and unfortunately, we don't have time to cover all of them, but we wanted to put some of them here, like, for example, the fact that oceans are warming up, and because the water is hotter, is more warm, then it's more difficult for oceans to absorb CO2 emissions, and even in some parts, it can release greenhouse gas emissions. Same for sediment floor. Pit bog warming, ice melting, the albedo effect. Maybe it can bring you back to some science course when you were younger, and other effects like the deforestation as well. Bottom line, and what's very important is that this green line that I mentioned earlier that doesn't impact a lot climate change, global warming, green line emissions from natural sources. Well, if we are above 2 degrees of global warming, this green line will increase. That's for sure. But by how much? Difficult to say. Some say that it can even go higher than the brown-orange line that represents greenhouse gas emissions from human activities. So the conclusion is, clearly we are emitting a lot of greenhouse gas emissions. It leads to global warming that will have a change in our climate. And the reality is, to reduce it, it's very difficult if we do not measure our own greenhouse gas emissions. This is what we keep repeating at different conferences, in papers, in articles. We cannot reduce what we do not measure. It's a bit like, well, a few years ago, I did a diet, a very strong diet. And guess what? The first thing that I did when I started my diet was to buy a scale. I wanted to measure where I was so that I could track my progress over time. It's the same when you meet a doctor. A doctor will never give you a medicine before having a diagnostic. And a carbon footprint assessment is this diagnostic that will help you in your private life, but certainly in your professional life for your company to to measure CO2 emissions in order to identify where to act and what to do. And unfortunately, right now, what we realize is that without a carbon footprint assessment, we make decisions blindly. And we noticed that in quite a lot of companies, investments that were made, resources that were invested in some or some other project without a proper diagnostic. And most of the time, not all of the time, but most of the time, it has quite the impact could have been greater if the measurement was done upfront. The European Commission understood it very, very well. So here in this graph, we are showing you the greenhouse gas emissions that are reducing, since 1919, and this is good news. But as you can see, to reach our target to be carbon neutral by 2050, we are not on track. So to try to be a bit stricter, more stringent with those emissions, the European Commission is now releasing, as of January 2024, a series of climate regulations that I just want to mention two of them, the CSRD and the CBAM. Maybe some of you are familiar with that, but the CSRD, that stands for Corporate Sustainability Reporting Directive, will bring something quite new in a environmental regulation, is the obligation to measure greenhouse gas emissions on your scope 1, scope 2, and scope 3. And I'll come to that in a moment. The CBAM is slightly different. It's the carbon tax. Maybe you've heard about it. And it requires from companies and suppliers to provide the GHG emission, the greenhouse gas emissions related to the production of the product that is imported in Europe. I hope everything is clear so far, and I'm not going too fast. But now we will go into a bit more technical aspects. And the first that I would like to address with you today is to describe what are we measuring when we are talking about a carbon assessment. So yes, we say a carbon assessment, but behind that, they are the greenhouse gases that we need to measure to be compliant with the regulations and the methodologies that we are using. And there are four greenhouse gases that we are measuring. CO2 emissions, of course, methane, coming from agriculture, landfills, nitrous oxides coming from residues from fuel combustions, fertilizers, and so on, and fluorinated gases that are the gases that you will find in your fridge, in your freezer, and so on. So instead of doing reports where you need to declare the quantity of emissions of each greenhouse gas, that could be a bit complicated, Scientific came with a sort of methodology to bring all these elements back to one common unit that we are all familiar with, which is CO2. But here we're talking about CO2 equivalent, standing for the fact that behind the CO2 equivalent, you have different greenhouse gases. And how can we convert methane, for example, into carbon dioxide? It's very easy. We need to take into account, and I'll make it very, very simple here, we need to take into account two variables. What is the global warming effect, or also known as what is the power to warm the atmosphere from this particular gas? And here, methane, for example, well, it's roughly 25 times more powerful than CO2, meaning that for 1 kilogram of methane that is emitted in the atmosphere, it has the equivalent warming effect than 25 kilograms of CO2. So methane is 25 CO2 equivalent. And the other variable that we are also taking into account is how much time the gas will stay in the atmosphere. Some gases will have a very short lifetime, and others could stay during millennia. And so there is a rule to follow to measure all these gases according to a certain period and consider only their warming effect throughout that particular period. And the objective of a carbon footprint assessment is to come up with this. So this is a screenshot from the products that our consumers are using. And it's a traditional greenhouse gas protocol report. I'll come to that in a minute, but the greenhouse gas protocol is a standard that is being used by companies all around the world to measure CO2 emissions. And here, it's like in accounting, they are accounts and you can't change their name. You can't change where they are in the report. That's how it is. You just need to take your emissions and to put it under the right category. And this is what we do with our software. If you'd like to go further in understanding the mechanism, the cause and consequences from climate change, we strongly recommend you to try a climate fresk. So we can certainly help you to organize that within your company if you want to raise the awareness of your people. And there are quite a lot of sessions as well that are accessible for individual in almost every cities now in Belgium, in France, and in most cities in Europe now. Now, let's go to carbon accounting, how to measure CO2 emissions. Well, let's start first with a bit of theory, and then I'll show you a case study. So what I will show you is what it looks like in our product to measure your CO2 emissions and to handle a carbon strategy. So first, the carbon footprint. Well, at D-Carbonize, we chose to align with two standards. The greenhouse gas protocol, that's the one that I mentioned earlier. This is the standard that we are seeing all around the world. And there is another standard, another protocol that is from the French ADEME, and this methodology is called bilan carbone. We very much like these two methodologies because we feel like they are complementary and they bring a lot of value in the values and the approach in the methodology that they recommend to follow in order to measure accurately and completely CO2 emissions. I mentioned accurately and completely. Yes, because it's the two conditions to have a good carbon footprint assessment. So if you need to remember something about carbon accounting, you need to meet two conditions. One, it needs to be complete, and two, it needs to be accurate. So let's start first with the completeness aspect. The completeness aspect requires to measure CO2 emissions at a complete scope. And there are three scopes. Scope 1 would be the direct emissions. To understand that, you need to visualize the greenhouse gas. We can't see those gases, but visualize them. Let's say that you can see them. That would be all the greenhouse gases emitted by your activities. And most of the time, that would be all the fossil fuels that you're using to power your machines, to heat your facilities, to power the cars that you are using. So diesel, gasoline, the emissions that are directly produced by your company for your activities. Scope number 2 would be qualified as indirect emissions, but related to the energy that you are using. And here we are mostly talking about the electricity consumption. Why is that? Because if you switch on the lights in the office where you are not emitting CO2 emissions at your office. The emission is emitted at the power station. And this is why it's an indirect emission, but related to the energy that you are using. And scope number 3 is literally the rest. Rest divided in two scopes. Well, in two different categories, upstream and downstream. Upstream, you'll find emissions related to the assets, everything that is owned by the company. Then you'll find mobility options. So that would be the commute, the transport from where your people live to the office or the manufacturing plant or wherever they need to work. And business trips, planes, trains, cars, even scooters or bicycles if you meet your customers by bike, but these trips need to be registered. Operating waste, so literally all the waste generated by your production. purchases, and most importantly, the raw materials that your company purchases for its activities. And then logistics, transportation, inbound logistics. So your goods, the goods that you purchase that are coming from by plane, by train, by truck, by van, we need to account for these emissions. The same for the logistics, needs to be reported for your downstream activities. When you ship the product that you produce, we need to record the emissions related to this shipment. Same for the product usage. If you manufacture a product and this product requires energy to be powered, like for example, the computer that I'm using today for this webinar requires electricity. This energy needs to be recorded in the computer manufacturer. Same for aircraft manufacturer or car manufacturer. They need to measure the CO2 emissions related to the fossil fuel that is used in those vehicles, and also the electricity. End of life. Well, still with this example of the computer, since right in front of me today, how this computer will end its life. Will it be recycled? Would it be burnt, incinerated? Would it be put in landfills? We need to have some information about that. Franchises and investments, it's a bit different. We will account here for the scope 1 and the scope 2, so the energy consumption of the franchises part of your group. Let's say, for example, you are a restaurant chain and you franchise your restaurants. Well, the energy used in your different restaurants needs to be accounted here. And investment is the same. If you're an investment fund, you need to record the energy consumption of your investees. At minimum, you can of course increase the perimeter, but that's the minimum that you need to report. Concretely, these are all the different categories from the greenhouse gas protocol. So I will not go through in too much detail here because these categories may be a bit more difficult to understand, and they go one level of details higher than what I just explained. But basically, everything that I just mentioned is covered by these categories. Now, how do we make sure that we have a complete scope? Well, very easy. We sit with the customer and we ask a lot of questions to understand how they do their activities. Where are the product coming from? What are the raw materials they are using? What is the energy that is used at the facility? What is the surface of the facility? The type of building, the waste, the assets. What is owned by the company? How is the mobility at the company? How are the goods are shipped? Who purchases the goods that are sold to customers? How the end customer is using the product, and so on and so on. And we literally map everything to create this cartography here, this mapping, to really understand where we need to collect the data. Now, the second condition is we need to have accurate data, right? Complete and accurate. And here, we need to bring this down to two different variables, activity data and emission factors. Activity data will be the data that we will collect at your company. For example, the tons of materials purchased, the kilometers that you're driving with your car, the kilowatt hour of gas, of electricity that is consumed. These are the activity data. And the more they are precise, the better it is. And then you have emission factors. And these emission factors are these small ratios that will convert, for example, 1 kilogram of plastic into CO2 equivalent. CO2 equivalent because thanks to these emission factors, we have the breakdown per greenhouse gas. And that's important because it's mandatory to report in the coming climate laws. And the end result is a CO2 equivalent, a result into CO2 equivalent. So this is a very short example to explain how it works in reality. And we use the impact frameworks, meaning for people, activity, consumption, and technology. So this example is very simple. It's, let's say, we will be looking at the commute of the people of this fictive company. Let's say we are 100 people commuting, well, 2 times per day, back and forth. And we live at 25 kilometers away from the office, so it's 50 kilometers. Time 5 working days, it's 250 kilometers. We are using, let's say, all of us, a car that consumes 6 liters per 100 kilometers, so 0.06 liter per kilometer. And we know, thanks to the emission factor, that 1 liter of diesel burns equal 2.64 kilogram of CO2 equivalent. And when you multiply everything, well, you've got your results, which is 3.96 tons of CO2, or let's say almost 4 tons of CO2. That would be for 100 people living at 25 kilometers away from the office and commuting every day with a diesel car. So that you already have a sort of some numbers in mind and some concrete examples how it works. All right. So now I would like to go one step further with you and to show you a concrete example of one case study that we did recently with our product. So we'll just shift here my window, and I will show you here. I hope everyone can see my window. Iris, maybe you can confirm?
I can see it, yeah.
Yeah, fantastic.
Guys, let me know in the chat.
Super. Welcome to our products, the D-Carbonize products, and I will show you how it works for one of the customers that we recently did. So these numbers that you're seeing here are based on a real case study, okay? So let's have a look at what we measured. We measure logistics flows, purchasing, energy, end of life, mobility, process that would be, if you remember, the chemical reactions or all the greenhouse gases that are produced without the combustion of fossil fuels. So for example, that would be fluorinated gases. You know, when you have a leak in your air conditioning, well, this gas is very damageable for the atmosphere, for the environment, and we count them into this category. Asset, waste, usage, and packaging. So obviously, for the sake of this webinar and demonstration, we anonymized everything, but so that you have an idea of what it looks like. We can see emissions per dimension, but also per scope, or also per category of the greenhouse gas protocol. You remember the ones that I showed you in the last slides of the presentation. For this customer in particular, we had 4 different sites. So in this tool, you can choose which site you would like to measure CO2 emissions. So here I put, for example, a site in Belgium, France, in Italy, and in the US. We call them entities. And an entity for you, it could be anything. It could be an office. It could be a manufacturing plant. It could be a business unit. It could be a country. It depends where you want to put the threshold. What is the level of granularity that you want to measure your CO2 emissions? And what's very easy with our tool is that you can shift from one entity to the other. Here we're in France in 2022, but there is no data. So I will shift to 2021, and I'll get the data of 2021 for France. If I want the data for 2021 for all my company, then I just click all of them, and I have my my emissions. Back to Belgium. Well, there is another powerful tool with our product, is that within your carbon footprint, you can measure CO2 emissions related to a particular flow. And we are using it to track CO2 emissions related to products, for example, or services or business units. Here, let's say we have 3 products. Well, we can select product 1, and we have the CO2 profile of our product 1 out for Belgium in 2021. If I need a greater level of detail, then I can go to the table below. In the table below, I will see here, for example, well, logistics seems to be a very a lot of emission. So if I go below and track for logistics, indeed, 25% of my CO2 emissions. If I click below, I have 2 categories here. And these ones are very very important for us because these are what we call analytical categories. So it means that logistics out and logistics in, these are categories that we created ourselves. And the reason is because we realize that for most of our customers, those dimensions or those categories from the greenhouse gas protocol or the three scopes, it's not always perfectly adapted to their own specific situation. So we really wanted to give them the opportunity to create their own carbon footprint report with their own labels. And this is what we call the analytical categories. So back to my example, logistics out in. I go to logistics in because I see here it's 23% of the total. I go a bit one step further, and I have three here, for example, three flows, one by boat, Asia, Antwerpen, one truck, Romania to the plant, and one truck, Antwerpen to the plant, for example. I have here my tags that are associated to my lines, and I can see the quantity, the CO2 emissions, and the percentage of total. And this is very powerful because here in this case, we could immediately see that where we need to work to reduce CO2 emissions, it's definitely on the truck flow from Romania to the plant. So what could be an immediate action is to pick up the phone and to call the logistics supplier and say, well, look, you represent 22% of my CO2 emissions. Can we sit together and think together what we can do to mitigate that? It will be, of course, in your benefit, but also in the benefit of the delivery, the transport supplier, because he will also reduce its CO2 emissions. Now, I just want to show you one example how it was quite useful to use the analytical category for that particular case study. Back to my product one, if I move to analytical category, we see the carbon footprint report of this product one under another lens. And here we can immediately see that indeed logistics in is a real issue, but raw materials is also a lot of accounts also for a lot of emissions. And if I go below here in my raw materials, I click here and I can see that I have a bit of plastic, steel, aluminum, and I can have the breakdown and as much detail as I need to analyze my report. Speaking of reports, our tool offers this feature that automatically creates a report in different standards. Bilan GES, that's the one that is commonly used in France if you have business with French companies or with France. GHG protocol and ISO. Very soon we will add here CSRD. You remember the regulation that we talked about at the beginning of this webinar. And you can just use this extract to share with partners, with suppliers, with investors, with customers. They will understand what this report is all about. So that's what I wanted to show you for this case study. It's very powerful to use a tool to really understand the CO2 emissions before moving to the next step, that is reducing CO2 emission, but that will be most likely for another webinar. We will not have time today to address that. Now, back to the presentation, I would like to show you these last few slides before we move on to the questions. We are now able to extract some KPIs because, you know, one of the first questions that we receive after we do a carbon footprint assessment is it good or bad? Very difficult to say because first, a carbon footprint assessment is made to be compared with the next carbon footprint assessment of your company. It's made to track your own CO2 emissions. It's very difficult to compare one carbon footprint assessment with another one because we may want to compare apple with pears. Sometimes the scope is not the same, emission factors are not the same, and so the results might be significantly different, which may bias CO2 emissions. However, with the way that we are doing carbon footprint assessment, complete and as accurate as possible, we start to get some very interesting insights. I put here 3 profiles of companies that we work a lot with: office companies, industrial companies, and financial companies, i.e. banks or investment funds. For the service companies, we measured that on average, a service company would emit between 8 to 10 tons of CO2 per employee, with one of the main aspects would be the services that are purchased by this service company. So services would be accountants, law firms, notary, consultants, external providers, and so on. And to give you an idea of how much lines a carbon footprint assessment is for a service company, it's around 80 lines. And industrial firms, well, usually the most important element would be the raw materials, the carbon footprint from the raw materials that are purchased by these industrial firms. Here, the range is a bit higher because it's very much dependent on what you manufacture. But usually we see between 30 to 80 tons of CO2 per employee. In the finance industry, let me tell you that on average, 95 to 99% of the CO2 emissions for a finance company will come from the investments, the investees. So that's why it's very difficult to put a number here, because if you're an investment fund with 100 investees or a larger investment fund with 1,000 investees, obviously the impact is completely different. But here in this case, you really need to take another approach to measure the CO2 emission from your investees. You need to collect a lot of data from them, and you need a different version of our tool to do that. To do quick scan, like we say, a carbon footprint scan, to quickly get data from your investees. Last but not least, what I would like to mention here is that it's important to improve your carbon footprint over time, and so to improve the uncertainty, reduce the uncertainty to be more certain about the results. And we have a dashboard for that puts in orange the categories of the greenhouse gas protocol where you're not good and you need to work on. So some conclusions before we move to the Q&A. It's very important to measure your CO2 emissions to make informed and efficient decisions, right? Resources around us is limited, so we should make the best use of it, and it starts with a diagnostic. Carbon assessments are interconnected. You will do your carbon footprint assessment, and it will help your suppliers and your customers to also measure their CO2 emissions. So we really encourage you to invite the players in your value chain to also measure CO2 emissions. It will be beneficial for everybody. And last, a carbon footprint assessment is a source of opportunity. We did not talk that much about it today, but it's a source to attract and retain talent. It's an opportunity to rethink your business and maybe offer new services, new products with that are less carbonated, which will offer a new value for your customers. Remember that most of the time, if you do not emit an emission, it means that you are not using a certain energy or you're not buying certain aspects. So it has a direct positive impact on your P&L and many other good benefits that you can get out of a carbon footprint assessment. I hope that you liked this webinar and was informed. We have other webinars that Iris will tell you in a moment.
Indeed. Don't forget to register to the next webinars. When we send you the presentation, you will find a scan code where you can, it leads you directly to the website where you can register. So we have planned a second webinar on how to manage CSRD reporting obligations. So what is the scope of the directive CSRD? Who is concerned by CSRD? When and how to start? Also, we have prepared another webinar about how to implement a good reduction strategy, where we will cover things of how to be aligned with the Paris Agreement and SBTi, how to define your own reduction objectives, how to build a strong carbon reduction strategy, and the latest webinar that we have organized is how to become a good ACG manager, where we will cover what is ACG overall, environmental, social, and governance, what are the responsibilities of an ACG manager, and how to communicate with internal and external stakeholders. And then I'm going to proceed with the question and answers. I cannot see any question in the chat, but you can write any while I go maybe.
Yeah, I think we got some questions from
actually. It is possible, so it's a question from Emily, thank you very much. It is possible to have a strong and accurate database for free.
Database of emission factor, I guess. And the answer is yes. I like to believe that such databases exist. So we are using different databases within our tools. So the one that we prefer for customers in Western Europe would be the base empreinte from ADEME, because this database is public. This database is updated quite often by experts, scientists, but there are other databases. DEFRA in the UK, very good, for example, for everything related to mobility, logistics. EPA in the US from the Environmental Agency of the US. The Greenhouse Gas Protocol also has its own database that is open. And then you have also private, very good databases, EcoInvent, for example, MSCI or Standard & Poor's for the finance industry. But that will be for more specific cases, I guess, if you have a real need to go very much in depth into one particular topic. Thank you, Emil.
From the electricity used in my computers, Scope 2, but the computer manufacturer has also can have to account for the same emission coming from its product uses, Scope 3 from indirect downstream emissions. So that causes the same emission to be double counted globally.
And that's right. That's right. I go back to this slide. You're absolutely right. At the value chain level, you will have a lot of double, triple, quadruple counting of the same emission. However, usually those emissions will be in different accounts. Let's take the electricity. If you use the electricity, it goes into your scope number 2, indirect emissions from electricity. But in the case of your computer manufacturer, it will go here in the use of sold products. So it's in a different category. And here, the objective is not to avoid double or triple accounting of it. It's just to identify where it is and who can act to reduce those CO2 emissions. If you don't want any double accounting, what you need to do at the global scale for all the value chains in the world is to sum up the scope 1 and only the scope 1. And then you will not have double accounting. But as you can imagine, we are miles away of this to be a reality.
Typically work with customers from industry. I guess refers to how long does it normally take to conduct the carbon footprint assessment for.
Yes, it's a very good question. So I'll give some generic numbers. It can go as fast as 1 month. We've done already carbon footprint assessment in a month, but it requires to have a very good storage of data. You know, you need to have a lot of data that is at your disposition and ready to be shared. But usually it's between 3 to 6 months. Remember that 3 to 6 months, it's not that long, but given the coming environmental regulations, well, better to factor that period. Because you cannot have a carbon footprint assessment overnight. So it takes a bit of time to be done.
Thank you so much for all these questions. They are super relevant. There is another one which says, I would like to know if you include the greenhouse gas impact of the use of the services sold by the service company and how you account for that.
It depends on the service. If the service requires energy. So let's take an example that we are quite often when we work with the development companies, you know, companies that are developing software. What do they do? Their service is to produce in the end a product, a digital product. And this product requires energy to work, to be operated. So in this case, yes, we include the energy. Now let's take another example. We do some law firms. Well, the service that they give doesn't require any energy to be used. It's pure consulting. So in that case, you cannot expect any emissions in the use of sold products. Thank you for the question, by the way. Yeah, sometimes a bit tricky.
Indeed, I think we have time for last question because we have a list of questions that we received previous to the organizing the webinar.
We can answer via email, maybe.
Yeah, we can maybe answer one more very quickly, which is relevant because some people might want to know how much time and energy do people in their teams need to dedicate to the data collection. And with regards to the other questions, we will send you an email with the recap so you are all aware of the answers.
Yes. Well, let's divide this into two elements. First, when we work with a customer, it's very important to have a SPOC. So someone that will be the person I will be speaking with on the customer side, someone who will be responsible for the assignment on the customer side, someone who will be the responsible of the tool, the software that we will equip the company. And this person, well, we expect that usually across an entire assignment would invest 4-5 days of his or her time to help us to navigate within the company, to attend meetings, to get trained to carbon accounting, to get trained to our products. And then we need to speak to people who have the data. We call them the data owners. And then it can range between half a day to maybe 1 day or 1 day and a half of their time to listen to what we have to say, because we do a lot of awareness with our customers. We try to explain them what is a carbon footprint assessment, give the key principles of carbon accounting, explain them very clearly what data they are expected to share with us. So overall, between half a day and 1 day and a half per data owner, of course.
For the rest of the questions, we will come back to you on the people who are not able to attend the webinar today. We will send a recap of the answers.
Thank you very much. Thank you very much for your participation today and your very interesting questions. Feel free to get in touch with us if you want to go further with the discussion. If you have additional questions, you have our email address here. We are at your disposition for the next steps. Have a very good day and hopefully see you to the next webinars. Thank you.